into 8 square. So it is 3 square into 2 power 3 into 2, 3 square into 2 power 6. So number of factors will be 3 into 7, 27. If I give you a number like 1001, what happens? What is this number? That is where comes the test of divisibility. How anybody will know which number divides what? So, number tested and the test to be conducted. How will you know a number divides 2? Number is even or the number ends in 0. Number 3, sum of the digits should be divisible by 3. You can take all single digits, same numbers, 111 or 333 or 777, or these numbers will divide 3, or any 3 running numbers will always divide 3. Test for 4. The number divisible by the last 2 digits should be divisible by 4. If we have 1024, it is 4 into 256. 24 divides, so the entire number divides, because 4 divides every hundreds and thousands. 5. Very simple. Number ends in 5 or 0. 6 is 2 into 3. So number dividing should be even number multiple of 2, and then you can test for 3. That means you can start with even, end with 11. These numbers will divide 3, and also they divide 2, therefore they will divide 6. Test for 7. 14 we know divides 7. The rule is last number you double and subtract. If you have 105, 5 is double, subtracted, remainder is 0. If you have 126, 6 is double, the remainder is 0. So the rule is double the last digit and subtract it from the preceding numbers to get a single remainder of either a 0 or a multiple of 7. Look at 1001. Last number is 1, double, 2, subtract, 98, 8, double, 16, subtract, which means 1001 is divisible by 7. It's about 8. The rule is number divisible by the last 3 digits should be divisible by 8. So 1, 2, 3, 4 doesn't divide, 5 doesn't divide, but 1, 2, 3, 4, 5, 6 definitely divides 8. Similar to 3, sum of the digits should be divisible by 9. So if we give you a number like 2, 3, 4 dash, what should come there? The least integer, or 3, 4 dash 5, or 5, 6, 7 dash. So the first case it is 0, second case is 6, third case is also 0. Sum of the digits must divide 9. 10 we don't need, we'll go to 11. Look at 11 square, 121. 11 cube is 1331. If we look at 121 separately, the outer digits 1 plus 1 is 2, the middle number is also 2, the difference is 0. That means, looking at the 3-digit number, if you want to divide by 11, the number will divide 11 if the outer 2 numbers equal to the middle number. So 2 dash 5 if I write, what should come there? 7, or 3, 9 if I write, it should be the other number is 6. The difference need not be always 0, it can be even 11. So what number should come there? 9 there and 0. That means 308 or 407 or 506, all these numbers are divisible by 11. If we go to 4-digit number 1331, sum of the alternate digits, 1 plus 3 is 4, 3 plus 1 is 4, the difference is 0. So the rule is the difference between the sum of the alternate digits should be either 0 or it can be a multiple of 11. If we take 1001, 1 plus 0 alternate digits, so 1 plus 0, 0 plus 1, the result is always, so the difference is 0. That means what? 1001 is divisible by 11. 12 is made up of 2 and 6, also 3 and 4. Which two factors should you try and why? Will you go for 2 and 6 or 3 and 4? We must go for 3 and 4, not 2 and 6. Why? Highest common factor of 2 and 6 is 2, whereas highest common factor of 3 and 4 is 1. And also LCM of 2 and 6 is 6, whereas LCM of 3 and 4 is 12. Therefore, the point here is select only co-prime factors. Because number dividing 2 and 6 is always divisible by 6, but need not divide 12. Example, 18 is divisible by 2. 18 is also divisible by 6, but is 18 divides 12? No, it fails. So keep in mind, select only co-prime factors. Let us go to some prime numbers. 13. 13 into 5 is 65. The rule says, if we take 65, last number 5 multiply by 4 and add to the previous number, that will be a multiple of 13, then the number divides 13. 143. 3 divided by 4, 12. The result is 26. Divides 13, or 1001. 1 is multiplied by 4 and added. 4 is multiplied by 4 and added. That means 1001 is also divisible by 13. 17. 17 into 5 is 85. The rule says multiply the last digit by 5 and subtract. When you subtract, you get the number divided. Or if you have a number like 3 by 7, multiply the last digit 7 by 5 and subtract, you get 0. The rule is multiply the last digit by 5 and subtract from the preceding numbers to get a single remainder, which is either a 0 or it can be a multiple of 17. Let's end with 19. What have we done for 7? We have to reverse. Now take 5 times of 19, 95. The rule says multiply the last digit and add. The remainder will be a multiple of 19. So we can write the rule is last digit into 5 and add. So if you look into 1001, we found 7 is a multiple, 11 is a factor of 1001. In fact, 1001 is made up of 7 and 11 and 13. So the number of factors of that will be 2 into 2 into 2, 8. A number divisible by 2 and 5 is also divisible by what? Next, a number divisible by 4 and 5 is also divisible by what number? Third question. A number divisible by 6 and 8 is also divisible by what? The first answer is 10, second is 20, third is 24. What we are finding is LCM. So, the first point emerges here is a number divisible by a series of numbers is always divisible by their LCM. Let us find LCM of 2, 3 and 4. When you have 2 and 4, you can forget 2. Then the LCM is simply 3 into 4, 12. That's the first case. First case is what? Both 2 and 5 are prime numbers. So generalize. The LCM of any two prime numbers is their product. Second case, 4 and 5 are co-prime numbers. So what can we generalize? The LCM of any two co-prime numbers is also their product. Third case, 6 and 8 are composite, but they are not co-prime. Therefore what happened? Their LCM is not their product. This is what you have to keep in mind. Some numbers. Number 1, 3, 4, 5. Number 2, 4, 5, 6, 7. Number 3, 5, 6, 7, 8. Number 4, 6, 7, 8, 9 and 10. First one, 3, 4, 5. They are consecutive positive integer co-prime, therefore the product will be the LCM 16. Second case, 4, 5, 6, 7. We find 5 and 7 are prime numbers, so only look at the composite numbers. Let's find the LCM of these two, and we find the LCM of 4 and 6 is equal to 12. So the required LCM will be 12 into 5, 16 into 7, 420. Number 3, 5, 6, 7, 8. Leaves 5 and 7. Look at the LCM of 6 and 8. So you find the LCM is 3 into 2 into 2 into 2, 24. The required LCM is 24 into 5, 120 into 7, 840. Number 4, 6, 7, 8, 9, 10. So we can find the LCM of the composite numbers. Start with the highest prime factor, which is 5. So we have 2 there. Then 3. Exhausts 3. We get multiples of 2. So whenever you have 5 and 2, mix them. Then the LCM is 5 into 2 into 9 into 4 into the number left out. So 316 is 7, 2520 is the LCM. Highest common factor or greatest common divisor. How to find highest common factor of numbers? Let us say 8 and 12. So 8 is made up of 4 and 2, 12 is made up of 4 and 3, so the highest common factor is 4. Another method is divide the bigger number by smaller number. Then the remainder becomes divisor, divisor becomes dividend, you go on till you get 0. That divisor is highest common factor. Let's take some numbers. 36, 54, 72. What is the highest common factor? If you know the factors, first number is 18 into 2, second number is 18 into 3, third number is 18 into 4. So you can easily write highest common factor is 18. If I give you another number, series of numbers 143, 195 and 273, one more method is write the number in ascending order, keep the first number as it is, this number, subtract the first from the second, second from the third. So if you subtract, you get 143, 52 and 78. Change of order, 52, 78 and 143. Again go by the cycle, 78 and 52, 26 and 65. Change of order, 26, 52, 65 or 26, 26, 13. You will find highest common factor is 13. Difference between LCM and HCF. LCM of 6 and 8 is 24. HCF of 6 and 8 is 2. If we multiply 6 and 8, we get 48. If we multiply 24 and 2, we get 48. Which means the product of any two numbers is equal to product of their LCM and HCF. So if you ask you, divide 385 into two parts such that the LCM and HCF of the two parts be 10, 50 and 35 respectively. HCF is 35, which means the two parts must be a multiple of 35. So let the two parts be 35x and 35y. So what do you get? Sum of the parts should give you the number 1. Then the product of two numbers is product of the LCM and HCF. Solving, we get x is equal to 5, y is equal to 6. So the parts are 5 into 35, 175, 6 into 35, 210. LCM of fractions is equal to LCM of numerators by HCF of denominators. Similarly, HCF of fractions is equal to HCF of numerators by LCM of denominators. So if you ask you to find LCM and HCF of 1 by 2, 2 by 3, 3 by 4 and 4 by 5, LCM will be LCM of 1, 2, 3, 4 by HCF of 2, 3, 4, 5. You can have a note saying what? HCF of consecutive positive integers is equal to 1. Therefore, the LCM is 12 by 1 is 12. Then HAF will be HAF of 1, 2, 3, 4 by LCM of 2, 3, 4, 5 will be 1 by 60. The LCM of two numbers is 45 times their HCF. If the sum of LCM and HCF is 1150 and if one of the numbers is 125, find the other. Since LCM is given in terms of HCF, let us assume HCF is equal to X. Then LCM is 45X. If you add them, LCM by plus HCF is equal to 46X. The sum is given to be 1150. So X, which is HCF, will be 1150 by 46, will be 25. So if you know HCF is 25, then LCM is 45 times 25. One number is 125. Let the other number be Y. Then product of two numbers is product of LCM and HCF. So Y is equal to 45 into 25 into 25 by 125, which will give you 225. How to find the digit in the units place in the expansion of 333 power 777, 777 power 999, 999 power 666. That means 3 power 777, 7 power 999. This product will end in what digit is a question. A number ending in 1, any number of times you multiply, 1 power n ends in 11D. Similarly, number ending in 5, n times 5 power n ends in 5. Or we take 6, a number of times, 6 power n also ends in 6. Look at 4, 4 power 1 is equal to 4, 4 square is 16, 4 cube is 64, and 4 power 4 is 256. So they are alternating between 4 and 6. So 4 power n ends in 4. If n is odd, 4 power n ends in 6. If n is even, which means 4 power 123, you can write easily 4, 226 will be 6. Similarly, 9 power 1 is 9, 9 square is 81, 9 cube is 729, 9 power 4 is 6561. So, alternating between 9 and 1, 9 power 1, n ends in 9 if n is odd, 9 power n ends in 1 if n is even. So 9 power 111, again we say write 9, 9 power 666 should be 1. 2, 3, 7 and 8. 2 power n. 2 power 1 is 2, 2 square is 4, 2 power 3 is 8, 2 power 4 is 16, 2 power 5 is 32, 2 power 6 is 64, 2 power 7 is 128, 2 power 8 is 256. So you find the last digits are repeated after the fourth power, so we call it as a cycle of 4. So 2 power n will give reminders 1, 2, 3 and 4, and we write the last digit. 2, 4, 8 and 6, which means 2 power 111 or 222 or 333 or 444. Cycle is 4, so we have to divide 111 by 4. So we can have a note saying that 4 divides every hundreds and thousands and 10,000. So 4 will not worry about the hundreds place. So it is 8 plus 3. Remainder 3 will give you 8. 20 plus 2. Remainder 2 will give you 4. 32 plus 1. Remainder 1 will give you 2. 40 plus 4. Remainder 4 gives you 6. 8 power 1 is 8. 8 square ends in 4. 8 power 3 ends in 2. 8 power 4 ends in 6. If you go up, 8 power 5 will give you 8. 8 power 6 is 4. 8 power 7 is 2. 8 power 8 will end in 6. So even this is a cycle of 4. Look at the table. 8 power 1. What are the remainders we have? The remainders are 1, 2, 3 and 4. We look at the last digit. Last digit. 8 power 1 ends in 8. 8 square ends in 4. 8 power 3 ends in 2. 8 power 4 will end in 6. So if you say 8 power 2, 2, 2, 8 power 3, 3, 3, 8 power 4, 4, 4, 8 power 5, 5, 5. We are to divide by 4, therefore the hundredth part is not necessary. This is 20 plus 2, remainder 2 will end in 4. 32 plus 1, remainder 1 will end in 8. 40 plus 4, remainder 4 will end in 6. 22 plus 3, remainder 3 will end in 2. Seven power n. 7 power 1 is 7. 7 square ends in 9. 7 cube ends in 3. 7 power 4 will end in 1. We go ahead. 7 power 5 will end in 7. 7 power 6 will end in 9. 7 power 7 will end in 3. And 7 power 8 will end in 1. Again, the cycle of 4. Look at the reminders. You can write 1, 2, 3 or 0. Look at the last digit. 7 power 1 is 7. 7 square is 9. Power 3 is 3 and last is 1. So 7 power 5, 5, 5 or 6, 6, 6, 7, 7, 7, 8, 8, 8 like before. The hundreds is not necessary. So 52 plus 3, remainder 3 will end in 3. 64 plus 2, remainder 2 will end in 9. 76 plus 1, remainder 1 will end in 7. 88 plus 0, remainder 0 will end in 1. 3 power 1 is 3. 3 square 9. 3 power 3 will end in 7. 3 power 4 will end in 1. 3 power 5 again 3. 3 power 6 will end in 9. 3 power 7 will end in 7. 3 power 8 will end in 1. So again a cycle of 4. We look at the reminders. 1, 2, 3, 0. Last digit. 3 power 1, 2, 3 and 0. So 3 power 6, 6, 6. 3 power 7, 7, 7. 3 power 8, 8, 8. 3 power 9, 9, 9. As before, we can cancel the hundredth digit. So it is 64 plus 2, remainder 2 will end in 9. 76 plus 1, remainder 1 will end in 3. 88 plus 0, remainder 0 will end in 1. 96 plus 3, remainder 3 will end in 7.
is equals to 2009 whole square plus 2010 whole square. Then find the value of under root of 2n plus 1. We are assuming here, let 2009 is equals to m. So n plus 1 can be written as 2009 whole square plus 2009 plus 1 whole square. That implies m square plus, we can write m plus 1 whole square, which results 2m square plus 2m plus 1. As m plus 1 whole square is m square plus 2m plus 1, already m square 2m square. And this is n plus 1. So by cancellation of 1 and 1, we will get n is equals to 2m square plus 2m. Now we require 2n plus 1 here as the question given. So 2n plus 1 can be written as 2 of 2m square plus 2m plus 1, and which results 4m square plus 4m plus 1. So that we can write it as 2m plus 1 whole square. So therefore under root of 2n plus 1 can be written as under root of 2m plus 1 whole square, and which results only 2m plus 1. And already we assumed m as 2009, and here plus 1 is nothing but 4018 plus 1 is 4019, and that is the option number A is the right answer here. A student was asked to add first few natural numbers. So long his patience is permitted, the student stops adding and give the sum of 600. When the teacher declared the result, it was wrong. The student found that he had missed a number during the addition. Now we have to find the number missed here. So let assume the number missed here be some x. Then after adding this all sum of the natural numbers, the formula is n of n plus 1 by 2, and here the number is missed. What the number is missed here? X is missed. So minus x is equals to 600. So that we can write here n of n plus 1 minus 2x is equals to 1200. And even we can write n square plus n minus 2x is equals to 1200. And this implies the compulsory thing is n of n plus 1 must be greater than or equals to 1200. So even so that n square plus n must be greater than or equals to 1200. If you observe these options given here, 20, 25, 35, 30. 20 square is 400, 400 plus 20 will be less than 1200 itself. Even 25 is also 625 plus 25 is 650 is less than 1200. And let us go to 30 here. 30 square is 900 plus 30 will be thus results less than 1200 itself. Now coming to 35. 35 whole square is 1225 plus again 35 1260, which is greater than or equals to 1200. So therefore we can write here the number is for smallest is 35. So we can write here n is equals to 35, so that 2x it can be written as 1260 minus 1200, nothing but 30 here, 60, so that x value is going to be 30. So the option D is the right answer here. 4312. So we have to factorize these 4312, so that we can write 4312 as 2 cube into 7 square into 11 to the power of 1. Now we require only odd factors, number of odd factors, so that we can write here odd numbers 7 and 11 we have, so that we can write 2 plus 1 and 1 plus 1. Nothing but 3 into 2 is 6 is our answer, and option C is the right answer here. Are integers and sum of reciprocals, so 1 by p plus 1 by q plus 1 by r is equals to 1. Then we require the value of r here. We are going to write here, first of all, given p is less than q is less than r. Already from the given condition we are writing this. So that we can write the reciprocals, 1 by p is greater than 1 by q is greater than 1 by r. Also given the sum of reciprocals, 1 by p plus 1 by q plus 1 by r is equals to 1. So therefore the average of 1 by p comma 1 by q comma 1 by r is 1 by 3. Hence we can write here 1 by p is greater than 1 by 3, and we know also 1 by p is less than 1. So by taking the reciprocals, we can write here 1 less than p less than 3, and already p is given as an integer, so therefore p can be written as 2. So already from the equation number 1 we can write here 1 by q plus 1 by r is nothing but 1 minus 1 by p, that is we can write here, that is 1 minus 1 by 2 can be written as 1 by 2 here. So proceeding similarly here, we can write we can prove 2 less than q less than 4. That is already we discussed here, q is an integer, so q can be written as 3. So here we got already p is equals to 2, q is equals to 3. Therefore we'll get r is equals to 6, and which is our required answer is option A. The number 445 is in decimal system, and we require this in to the base 6. So by taking the number 445 here with 6, we are taking short division. So it goes 6 7s are 42 and 25 should be there. 6 7s are 42, 25. So it goes to 6 4s are, that is we can write it as, and the remainder is going to be 1. Again if we are taking with 6 12s it is going to be, and remainder is going to be 2. If you are taking again with 6, it is going to be 6 2s are, the remainder is going to be 0. So this implies 441 to the base 10 can be written as 2021 to the base 6. So this finishes the answer, and the option B is the right answer. For the least positive integer, that should be subtracted from 2010 into 2011 so that the difference is a perfect square. Let the required number be x, so that we can write here 2010 into 2011 minus x is equals to, it should be the perfect square, that is we are writing 2010 whole square. Sir, especially why we are writing this 2010 whole square, since 2010 whole square less than 2010 into 2011 less than 2011 whole square. We require here least perfect square, so that's why we are taking 2010 whole square. In the next step we can write x is equals to 2010 into 2011 minus 2010 whole square, and we can write it as x is equals to 2010 into 2010 plus 1 minus 2010 whole square, so that we can get the value of x here as 2010 common, and 2010 plus 1 minus 1 is nothing but we can get the value of directly x is equals to 2010. So the option goes to option D here. In decimal system, and it is equal to 1 2 3 4 to the base x. Now we require x, so we should go by options here. Let us check with 7. 7 ones are, and this is going to be 7 twos are. Next 54 will be there, 7 sevens are 49, 5 remainder. Again with 7, 7 threes are 21, 6 will be there. And this can be written as 365 off to the base 7. But here it is given 1, 2, 3, 4. So let us check next 194 with 5 according to option B. 5 threes are 15 and remain 4, 8. 44 is going to be 40. Next remainder is 4. 5 sevens are 35. Remainder is 3. 5 ones are remainder is 2. So 194 to the base 10 can be written as 1, 2, 3, 4 to the base 5, which is in our question 1, 2, 3, 4 we have. So the option number B is going to be the correct answer. 4 to the base B is the square of the number 24 to the base B. Then we require the B value here. That is given here 54 to the base B can be written as 5b square plus 5b plus 4. And another number is equals to, this number is equals to square of 24. So we require 24 to the base B whole square. That is 2 into B plus 4 whole square. So these given are equal. Now we have to equal these. So what you will get now, 5b square plus 5b plus 4 is equals to 2b plus 4 whole square, which can give 4b square plus 16b plus 16. Now we can simplify this and we can get 5b square minus 4b square is b square, and 5b minus 16b will be minus 11b, 4 minus 16 will be minus 12 is equals to 0. This is in the form of a quadratic equation. By taking the factors we will get b plus 1 into b minus 12 is equals to 0. So this implies b is equals to minus 1 or b is equals to 12. But b is equals to minus 1 is not possible, since b should be greater than 1. So therefore b can be taken as 12, and the option is goes to option D. Given 1 2 1 1 2 2 1 1 1 2 2 2 and 4 ones and again 4 twos. Find the first digit from the left of the base 9 representation of A. Here what is given? Given A is equals to 1 2 1 1 2 2 1 1 1 2 2 2 1 1 1 1 2 2 2 2 off to the base 3. Now if you count from the left we require, if you count from the right, first number will be the 19th. So we can write A is equals to 1 into 3 to the power of 19 plus 2 into 3 to the power of 18 plus so on. In the next step we can write here mixing of these two, 1 into 3 to the power of 19 plus 2 into 3 to the power of 18 plus so on. 1 into 3 to the power of 18 into 3 plus 2 to the power of 2 into 3 to the power of 18 plus so on can be written here. Now if I am getting 3 to the power of 18 common here, 1 into 3 plus 2 and 3 to the power of 18 plus so on can be written as. So 3 plus 2 into 3 to the power of 18 can be written as 3 square whole to the power of 9. That implies we can write here 5 into 9 to the power of 9. So the required first digit of A is going to be first digit of A in 9 representation is 5. So the option B is the right answer here. nearest to 16438, that should be exactly divisible by 11 as well as 7. Now the number which is divisible by 11 and 7 will automatically divide with 11 into 7, nothing but 77. So if you are dividing the number 16438, then we will get here 77 twos are, we can write 154, 10, 103, ones are can be written as 77, and remains 26, 8 is there. It goes with 3 times, that is 231, and the remainder is going to be 37 now. Now the remainder we are getting is 37. So the number we require is 16438 minus 37 is nothing but 16401. So which gives option number C here. And here we have another method also. That is, the divisibility condition of 11 says the difference of the sum of alternative digits must be divisible by 11. If you observe the set A, option A, 1, 6, 4, 3, 5. 1 plus 4 is 5, 5 plus 5 is 10, and 6 plus 3 is 9. The difference of this is going to be 1, but it is not divisible by 11. Next, coming to option B, 16483, 1 plus 4 plus 3, 5 plus 3 8, and 6 plus 8 is 14. Even the difference we are finding 6, this is also not divisible. Next, coming to 16401, 1 plus 4 plus 1 is nothing but 6, and 6 plus 0 is 6. The difference is going to be 0 here, which is divisible by 11. Coming to option D, 16430, 1 plus 4 plus 0 is nothing but 5, and 6 plus 3 is 9. The difference is 4, which is not divisible by 11. So the only option C we are finding here, and that is option C is the right answer. Into 1531 into 1533. If the same number is divided by 13, then what the remainder we are going to get? Now we know 1521 is divisible by 13. So n can be written as 1521 plus 8 into 1521 plus 10 into 1521 plus 12. Now the required remainder will be the remainder obtained by dividing this 8 into 10 into 12, that is 960 by 13. So 960 is divisible by 13. We can get the remainder as 11. So therefore the remainder can be given as is obtained by 960 with 13 is 11. So the option goes to option C. Fishes increases by 1 every day when compared with that is previous day. Now we require the number of fishes in the end of 100 days is. On the first day the fish will be only 1. On the second day another one is going to be increased, so 2. So like this every day it is going to be increased by 1. So At the end of the day, it is going to be 100 fishes. So the total number of fishes is equals to 1 plus 2 plus 3 plus 1 plus 100. This is nothing but sum of natural numbers up to 100. So we can take here the sum formula is n of n plus 1 by 2, nothing but 100 of 100 plus 1 by 2 is 50 into 101 is nothing but 5050. So the answer goes to C. What is the remainder when 16 cube plus 17 cube plus 18 cube plus 19 cube is divided by 70? So here the given expression is 16 cube plus 17 cube plus 18 cube plus 19 cube. So that we can write here 16 cube plus 19 cube in one bracket and 17 cube plus 18 cube in another bracket. If you observe these two brackets, these are in the form of a cube plus b cube. So we can write it as a plus b, that is 16 plus 19 into 16 square minus 16 into 19 plus 19 square, and again 17 plus 8 into 17 square minus 17 into 18 plus 18 square we can write here. Now 16 plus 19 becomes 35, and here if we observe this, 16 square is going to be even number and 19 square is going to be odd number, and this becomes odd number minus odd number results here, odd number we will get here. So 16 square plus 19 square and all these things is going to be odd number, and even 17 plus 18 gives 35, and even here also we will get odd number. So that we can take 35 common here, 35 of odd number plus odd number. Odd number plus odd number results an even number. Now we are going to divide with 70 here. Even number is nothing but it's a multiple of 2. So 2 can be multiplied here with 35. It becomes 70. So that the given expression is a factor of 70. So what we can say here, therefore the remainder is going to be 0. So the option in the given is A is the right answer here. We have to find the units digit in the expansion of 1 factorial plus 2 factorial plus 3 factorial and so on up to 2010 factorial. If you observe the first term, it results 1 factorial is nothing but 1, and second term 2 factorial is 2, third factorial, that is 3 factorial is 6, and 4 factorial is 25. Now from 5 factorial onwards, actually 5 factorial value is going to be 120. So from 5 factorial onwards, all the units place will be, whatever the numbers we are getting, the units place will be 0 we will get. Now if you are taking the summation of all this, that is 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial plus so on. 1 factorial is 1, plus 2 factorial is 2, plus 3 factorial is 6, 4 factorial is 24, plus 120 plus so on. Now if you observe all this results 33. And even after all these terms we have 0 here in the units place. So 0 plus 3 is going to be 3. So therefore the units place occupies with the number 3. So the option number C is the right answer here. Two numbers is 528 and their HCF is 33. How many such pairs of numbers are possible here? Now what is given here? Given HCF of two numbers is 33. So let the numbers are 33x and 33y, where these x and y are co-primes. Now what we can write here, also given that sum of these two numbers is going to be 528. So therefore sum of 33x plus 33y is nothing but 528, and this implies I can write 33x plus 33y is equals to 528, and which gives x plus y is equals to 528 by 33 is nothing but 16. So here what we require, here we require the pairs of the numbers which are possible as x plus y is equals to 16, and the one more thing is these numbers must be co-primes. So we may observe here the possible pairs we can write the first pair we are writing here 1, 15. These two are co-primes. And second pair we can write here 3, 13. Third pair is 5, 11, and next pair is 7, 9. So no other pair can be formed as co-primes of these two numbers. So how many pairs we are getting? 1, 2, 3, 4. So therefore required number of pairs is 4, and the option number C is the right answer. The integer n is the smallest positive multiples of 15 such that every digit of n is either 0 or 8. Find sum of the digits of n. Now what is given here? N is the smallest multiple of positive multiples of 15 we can write. So the same we will write here, given n is the smallest positive multiples of 15. So 15 means what we can say here, n is a common multiple of 5 and 3. Now we require all the digits either 0 or 8 in this n. So we can take n must be a digit which is containing a number of 8s. How many you have to take here? That must be equals to a multiple of 3. So that means what we can take here, we can take any number of 8, and the number of 8 if you are taking, the digit must be multiple of 3. So by checking trial and error we can write here, hence in view of required value, already we discussed there should be only 8 and 0. So 8, 8, 8, 0 we can write, which is divisible by 15 as well as 3 and 5. So what we require here, sum of digits. So required sum of digits of n is nothing but 8 plus 8 plus 8 plus 0 is 24. So the option goes to option D. Which of the following numbers is going to be greatest? The first one is 3333 is given. Second one is 33 to the power of 33, and the C is given 3 to the power of 333, and the D is given 333 to the power of 3. If you observe this, first one is 3333, that is 3333 is very less value according to my sense. Next we have here 33 to the power of 33 and 333 power of 3. Even 333 power of 3 is also very less value. Now we have to consider about B and C here. Let us take the option C here, that is 3 to the power of 333 we can write. And this 3 to the power of 333 can be written as 3 to the power of 9 into 37. So that we can write 3 to the power of 9 whole to the power of 37. Now if you observe this B and compare B and C, B is 33 to the power of 33 and C is we are getting now 3 to the power of 9 whole to the power of 37. So 3 to the power of 9 is nothing but 3 to the power of 3 we can write 3 times and the answer goes to 19683 whole to the power of 37. So here among all these values the option C value is going to be very big. So that's why we can write clearly 3 to the power of 333 is the greatest integer we require here. So the option goes to option number C is the right answer here. Positive integer n has exactly 12 distinct positive divisors, but only 3 distinct prime factors. If the sum of these prime factors is 20, then compute the smallest possible value of n. Here 4 options are given. So what you are taking here, let A, B, C are prime factors. And also given that the sum of these prime factors is 20. So we can write A plus B plus C is equals to 20. If the sum should be 20, then compulsory one of these is going to be even prime. So in this we can write one must be an even prime. So automatically the even prime is only 2. That is only 2 we can write. So therefore let A can be taken as 2 here. And the remaining 2 can be B comma C can be either 5 comma 13 or 7 comma 11. Only for these 3 we can possible, and these 3 it is going to be 20. Let n is equals to, we are taking 2 to the power of L, 5 to the power of M and 13 to the power of N, or 2 to the power of L, 7 to the power of M and 13 to the power of N. Now what we require here, we require number of positive divisors. The formula for positive divisors we can write m plus 1 into n plus 1 into L plus 1. It's already given that 12. So here m, n and L always should be greater than 0. Now we require the least positive integer, least positive value. So that's why we can take here either n is equals to 2 to the power of 2, 5 to the power of 1, 13 to the power of 1, or 2 to the power of 2, 7 to the power of 1, 13 to the power of 11 to the power of 1. So that the value of 2 square and 5 and 13 can be written as 260, or this value 2 to the power of 2 into 7 into 11 can be given as 308. So these both can be possible. In between these we require the least, that is smallest possible value. So therefore we can write the smallest possible value of n is, we can write 260. So automatically the option goes to option A, which is our required answer. In the place of the numbers of in the form of x comma y, where x and y are natural numbers, satisfies x to the power of 4 minus y to the power of 4 is equals to 2010. What is given here? Given x to the power of 4 minus y to the power of 4 is equals to 2010. Now it can be written as x square plus y square of x square minus y square is equals to 2010. Here we are taking case 1. If x is even and y is also even, then what it happens? Then x square plus y square is a multiple of 2. Why it is? Why? Because x square is an even number, even y square is an even number. Adding up these two even numbers, we'll get even number, so that it's a multiple of 2. And x square minus y square will be also a multiple of 2. So that we can write the product of these two, x square plus y square and x square minus y square, will be a multiple of 4. And if you observe the given number, it is 2010. We can write this 2010 is not a multiple of 4. So this is the first case. We are proving that there is no pair such x comma y should be formed here. And in this case we are not proving, we are proving that no pair. And even similarly we can prove another 3 cases. What are the other 3 cases? Another 3 cases are x is odd, y is even, x is even, y is odd, and x is odd, y is odd. So we can write, therefore the pair of the form x comma y does not exist. So the option D is the right answer here. A is 1996 by 1995 into 1997, and B is 1997 by 1996 into 1998, and C is 1 by 1997. Now we have to compare all these 3. Let us consider B by C. That is, what is B already? 1997 by 1996 into 1998, and again what we have tried here, by 1 by 1997, which results 1997 whole square. In the next step we can write 1997 whole square by 1996 as 1997 minus 1 and 1997 plus 1. So that we can write it as 1997 whole square by, this is in the form of a plus b and a minus b, 1997 whole square minus 1. If you compare this numerator and denominator, numerator is greater than denominator, so that we may get greater than 1 here. This implies b by c is greater than 1, nothing but b is greater than 1. Make this as equation number 1. Next we consider A by B. That is, what is A is 1996 by 1995 into 1997 into by B is, that is a reverse of this if you are writing, 1996 into 1998 by 1997. If you are splitting this, we can write it 1996 whole square by 1995 into 1997 whole square, and in the numerator we will get 1998. Just by splitting this, what I can write here, 1996 whole square by this 1997 can be written as 1995 can be written as 1996 minus 1. So that into 1998 by the remaining 1997 we can write here. Here one more 1997 is there. If you are multiplying 1995 and 1997 as previous, we will get here a square minus b square form, that is 1996 minus 1 here. And if you observe this, the numerator is greater than denominator, here also numerator is greater than denominator. So this implies greater than 1. And again we can write a by b greater than 1, nothing but a is greater than b. equation number 2. So from 1 and 2 we can write A is greater than B and B is greater than C, which results C is less than B less than A. And if we go to the options, the option D is the right answer here. Require here the maximum value of x for which 2 to the power of x divides 21 factorial. Here given 21 factorial. So this 21 factorial can be written as in this problem it was given find the maximum value of x for which 2 to the power of x divides 21 factorial, where the options are given that A is 1 and B is 18, C is 17 and D is 20. Now what we have to do here, we have to do first of all given 21 factorial. So 21 factorial can be written as 21 into 20 into 19 into so on up to 2 and 1 we can take here. Next 21 factorial, in this we have 21 numbers and except this one we have 20 numbers. Product of any odd number and even number is nothing but even number. So 21 factorial is the product of 10 even numbers and each of which has a factor 2. Next, if you again multiply two numbers, we will get here 5 multiples of 4 and each of which has a factor 2. And again after multiplication we will get here 2 multiples 8 and each of which has a factor 2 here. And at last 1 is a multiple, that means a multiple, 1 multiple we will get of 16 which has another factor, that is a factor of 2. Therefore we can write x is equals to, first of all we have 10 even numbers, that is 10 multiples and 5 multiples, 2 multiples and 1 multiples. Totally we are going to get 18 multiples here and the option B is the